All right, we're going to actually be a little ahead of schedule. Is everybody ready to move on to the next one? We've got so many good labs, there's really no way you'll get them done today. So you can attempt it, but I doubt that you will. And I can, after mine, I can walk you kind of through the lab. My lab's kind of exploratory on the website, so not a lot of code in it. So the exam portion that I'm working on is the design Azure Web and mobile apps. I don't have someone to introduce me, so I have a slide here to introduce myself. JasonHaley, I'm an independent consultant. I do mostly Angular and Azure. I am an MVP, brand new. I haven't been MVP very long. I have taken all 3 of the exams. I took this exam about 3 weeks ago. So if you want to know anything about it that I can share, there's certain things I can't share, of course. Come find me. I can give you some tips. And there's going to be a session tomorrow on exam tips too. So for those of you who are actually going to take the exam and not just here to learn the stuff, I would definitely check that out. For myself, I can know the material inside and out, but exam tips help. So I would definitely come for that if you're really going to take the exam. So those are the 2 that I'm going to focus on, is the web apps and the mobile apps. So someone asked a question about networking and web apps. I'll address some of that one. So that's the blurbs that are on the site. I won't read them to you. So with the web apps, so I'm going to focus on the web apps, then the last half dozen slides or so on mobile, because there's not as many pieces for the mobile that are just mobile specific. So some of the products that you'll need to know are, the app service umbrella. So the web, mobile, web API, and to some extent Azure Functions, though not so much. But it's good to know something about functions, which I'll get to in just a second. It's the next slide. SQL database, you're going to need to know something about SQL database, Azure AD, notification hub, VPN, hybrid connections, and CDN, and then, of course, traffic manager. That's a big one. Security options, so your security options for the app services, you need to know like the Azure AD and the external identity providers and how you would connect those together, and we touch on that in a lot of the sessions, or at least 2 of the sessions. Deployment and scalability, high availability is very important, especially for business continuity and disaster recovery. So that's kind of a high-level overview of stuff that you kind of want to have your head wrapped around for this. And about the Azure Functions things that I mentioned, you may not be tested on it, but you're going to really want to have a general idea of a lot of the Azure products. So at least you'll know what it's related to, so you can rule it out as one of the choices on the exam as fast as possible. Because that's for me, that's what a lot of it comes down to, is when you're looking at the multiple choice ones or the step ones that have like 7 steps, what are the 5 and what order are they in? You want to rule the 2 out that you don't need as fast as possible, so you can then order the ones that you do need. So just be familiar with as many of the products as you can. That's the tip for here, because there may be a few products that totally aren't on the exam requirements that show up as choices in the answers. And those are freebies if you know that it's clearly not related to what you need. But if you aren't familiar, then you might choose it because it sounds, a lot of the product names sound like they might actually have something to do with that scenario, but they aren't. You just need to know. So app service, it's this group of products. The web apps, mobile apps are basically what I'm going to be discussing, but there's also logic apps and API apps. API apps and mobile apps are similar. They're pretty much the same thing without the mobile device piece and the use of the SDKs. So it's a public endpoint that you can hit with a website or mobile device or what have you. But the API is just more generalized. It's not mobile specific or has no web UI pieces to it. But the great thing about app services, you get all of these items listed on the side there. You get the authentication, you get the backup restore, you get deployment, you get the networking tying in, scalability, and you get WebJobs. All of those with each of those products. So keep that in mind. With the web stuff, the web stuff and the mobile stuff have a lot of overlay, and the API have a lot of overlay, but if it's regarding authentication, backup, restore, any of those things listed, they're the same across the board. So if you're looking at the mobile apps and they ask you about, need to do on-premise authentication for a mobile app, well, how would you do it with a web app? Because it's all the same underlying scenario, except for the SDK running on that mobile device. So that's going to be your big difference. So keep that in mind. Probably can't read this slide. I can't even read it standing right here. You get the slide deck. Check this out. This is on the website. It's just a screenshot of the website. Sorry, it just didn't turn out for this resolution. It's a table that tells you, actually, you know what? I probably don't have time to jump out, but it basically tells you all the stats, what tiers there are. We have the free tier, the shared tier, basic tier, standard tier, premium tier. Yeah, boy, this really throwing me off. But it gives you all the stuff on app service and web apps. So you'll want to check that out, and you'll want to check that out for each of the products and be familiar with it. That's kind of the things that you're going to need to know for the exam. The free and the shared, you won't need to pay so much attention to, but you'll need to know why would you use a basic versus a standard, and why would you use premium versus a standard and a basic. That's the things that you'll really want to know from that chart. And what are the deciding factors? Like for a standard, you can have up to 10 instances, but if you need 12 instances, well, that means you're going to need to go to a premium. So that's the sort of things that's on that table you want to check out. So with App Service Plan, it's sort of the container that a web app, mobile app, or API app runs in. It's kind of compares to, say, a VM in the machine. So what size of processor do you need? How much RAM do you need? You get to kind of pick from sets of, they call them SKUs, and instance sizes. So you get the free, shared, basic, standard, and then between basic, standard, and premium, you get different levels, different core amounts, different RAM amounts, that sort of thing. That's your app service plan, because that's what needs to exist before you can even put a web app on it or a mobile app or anything. And that's the key thing about an app service plan, besides it's the container that runs your stuff. And I don't mean container as in Docker container, those sorts of things. I'm just using it in a general sense. Those have to be stuck in a region. So they have to physically exist somewhere. So that's another thing you might really need to know is what needs to be stuck to a region and what can really exist without a region. So that's app service plans. And with that in mind, here's a question. You have a web app that is deployed in 2 data centers, a common scenario from my experience. So you have an East Coast and West Coast. And you want to use Traffic Manager, which is going to be the least expensive plan that you can use to actually use Traffic Manager is what it's coming down to here. And that's where that unreadable table the unreadable table actually had the answer to this. So I won't keep you guys under suspense since you couldn't read the table. It's basically, it's a standard plan that you had to have to get to Traffic Manager. Yep. Yes. Oh, yes, sorry. So the question is, if you have a standard plan and you need to move to a premium plan, can you move from standard to premium? And the answer is yes. That's actually called scaling up. So you can move from a free to a shared, and you can even move to a free to basic, standard, whichever. Web apps make that really easy. And a lot of products across Azure make that easy to do. Some of them don't. Like, for instance, Azure Search doesn't. So if you do move it, well, then you've got to recreate your instance and start over. And there's certain things that you will run into if you go with premium SKUs that if they're not supported in a lower one, you can't necessarily go back down at that point. And the one that's really a big gotcha on that is the Redis cache, because there's so many features in the premium that just aren't supported in the others. So you kind of have to blow it away and start over if you need to go down at that point. But most products allow you to move up and down pretty easily. So with web apps is kind of the new kid on the block when it comes to platform as a service. Cloud services was the first one. And then, of course, they came up with the virtual machines. So we've got our IaaS, which is the cloud apps, and the virtual machines is the IaaS. Then cloud apps, those are your two choices, old school, classic Azure, but web apps is the new guy, and he's getting all of the investment and the features and ease of actually using things to do web apps. It makes it a lot easier. Cloud services is kind of the shunned stepchild at the moment. They don't do a lot with it, yeah. Doesn't support Java? Web app does support Java, yeah. It's just not up there, yeah. Good eye. So web apps does support Java. I just don't have it on this slide. Sorry about that. But yeah, good point. I think the other ones, and some languages that are not on here are available through a website extension. So you can add languages a lot easier than you can add frameworks that need to be registered on the machine. So high level response to the objective domain of design Azure App Service Web Apps is, well, it's a platform as a service. It's the newer technology. So it's the Azure Resource Manager technology, not the older school cloud services. That's the ASM. Then you can integrate web apps really well with existing tool sets, especially if you are a Java shop or a Microsoft Visual Studio shop, because you've got Visual Studio integration, but it also goes well with VSTS and other build systems like Git, GitHub. I mean, granted, those aren't necessarily build systems, but build systems are in that environment. So web apps integrate really well with those tool sets and life cycles. Other options that you may need to know for hosting web apps are, of course, a virtual machine. You can host a website on a virtual machine. More setup to do so, but you can do it. Service Fabric is another one that's typically going to be a microservice architecture. And cloud services, those are the older ones. So with that being said, when creating a website in Azure, which services can you use? Or really, which one can't you use? Yeah, so Flow is not a website hosting environment. So those three you can actually use to do a website. So here's another tip. You know, there are a lot of services in Azure that do the same thing. So like what you said, you can do websites and VMs, cloud services, or web apps. But if the scenario says you need to RDP into a machine, that's just a support scenario, they're going to do RDP, well, then you can't do it in web apps. So you'll need to know, what are the drawbacks with one scenario versus another scenario. That's just what I wanted to highlight here, that if you need to RDP, you can RDP into a cloud service and you can RDP into a virtual machine, but you can't RDP into a web app. So there's also this objective domain about design custom web API, and that is kind of in regards to just the API app in app services, but that RESTful service that's doing JSON or XML over a public endpoint is pretty much what it comes down to. You can write them in ASP.NET, you can write them in Node.js, and as I point out here, the app service, there are three options that you can actually host web APIs out on web apps, or app services, I should say. Web apps is the common one. If you need a public web HTML or generated HTML technology, you're going to need to go with the web app because it's not on the other ones. WebJobs. WebJobs are a way to run background jobs or background logic or long-running tasks, as they often call it. Very, very flexible. There's 2 levels. So a lot of them really are just run a script or run a script at noon every day or run a script first thing in the morning every day to send out an email. Something like that, WebJobs works really well for. You've got choices of just your batch files, your command files, PowerShell files, or you can go write subsystems and run EXEs as a web job. You can do them so they're always running. That's a continuous web job. And one of the key things you'll want to remember, if you're doing a continuous web job, turn on that always on the web app, or otherwise it's not going to continuously run. That's important to remember. On demand means you deploy the web job out there, but you get a UI or you can call a webhook to just tell it when to run. You've got it out there, and it's ready to run. You just push a button or whatever when you want it to run. And then you can schedule it. So you can schedule a web job to run using the Azure Scheduler behind the scenes. But schedule one. There are some scaling options with web jobs. So with a web jobs, it's running an app service. Typically, you're going to have a website, and you want some background jobs to run. And if you have a continuous one running all the time, and you have the web app, you can have the need to scale out your web app to maybe 3, 4 instances. So what does that mean for your web job? Because that's running on the same sources as your web app. Do you want that web job to now have 3 or 4 instances? Those are things you need to take into account with the web jobs. You can say, no, I don't want it to scale. I want it to stay singleton and be only on 1 instance running. Or you can say, okay, if load's getting bigger on the website and it's scaling out, go ahead and scale out the web job so there's multiple instances as well. It's all scenario-based there, whatever you need. The WebJob SDK, I don't believe the exam gets into it very much, if at all. But it's a binding and triggering system that is sort of the first phase of how functions became what it was. It allows you to do event-based logic running in web jobs. Very, very powerful. So with which of the following technologies can you build a web API with? And again, it's going to be quicker. Which ones can't you build API with? ADAL? Yep. Angular? Yeah, that's it. So 1 and 2 are Node technologies, and then 3, of course, is ASP.NET Web API. And I put that on there because the exam has some stuff that's Node sensitive. So it's not just ASP.NET Web API. You might really want to pay some attention to Node.js as well. So what's the best option to add background processing to your web API? Spin up a virtual machine, cloud services. Well, we can rule that one out because we're not talking about cloud services. Worker roles, that's also cloud service related. Doesn't make sense. A network security group has nothing to do with background processes. You can rule that one out. So it's just web jobs. Okay, so now let me get into security. So you guys haven't had the security talk yet, have you? No? Okay. So the security talk gets into this a lot more. So I'll just kind of pay attention to what's web app specific or app service specific. Azure AD B2B collaboration allows you to invite people that work for other companies and keep track of them on your Azure AD. And that means that you can connect your authentication of your web app to your AD, but have other external people connected to it to do your authentication and manage rights and all of that good stuff. But with Azure AD B2C, you can kind of do the same thing, but the main difference here is Azure B2C is more geared towards, say you have a web app, and that's really your primary existence for a company is your web app, and you deal with consumers. So that's going to be your Azure B2C, because that's the scenario where it would make sense to have Facebook logins, Twitter logins. That scenario makes sense with a web app or a website that's consumer facing and deals with consumers versus, say, a Microsoft or an enterprise that's dealing with a lot of other enterprises. That would be your Azure B2B, even though you can do kind of some of the same things. But B2C is more geared towards the enterprise-y. Again, you probably can't read this. You do get the slide deck. The security talk goes into a lot more about this. This is just more detail about what the differences are between the B2B collaboration and the B2C of Azure AD. So if you want to secure your app services, these are your main options. If you have a scenario, thinking of the exam here, if you have a scenario where they're saying you need to make sure that your on-premises users can or have to authenticate to use your web app, that means you're going to be doing an Azure AD that's syncing up with your Azure AD, because you can't just simply turn on Windows off in a web app. You've got to sync up with an existing directory and then have that directory authenticated against. Azure AD B2B, which I kind of just mentioned, would be an additional ability to using the on-premise AD, or not even worrying about on-premises AD, but it'd give you the ability to provide logins for people that work for other companies to your application. If you want to allow them to use Facebook, Google, Twitter, or a Microsoft account, you have two choices. You can do an Azure B2C, or you can just use App Services Authentication, which the lab touches on that. There are two options with that. There's actually three options. You can do it in code too and not use any of those tie-ins. So there are multiple options. So you have an on-premises MVC app, a website that uses Windows authentication. Which of the following items are steps you would need to take in moving to Azure? So you would need to create Azure AD. SQL database doesn't have anything to do with it. Create and deploy as web app. Okay, that makes sense. Create a Redis cache doesn't make sense. You wouldn't really need to do that. Add application to Azure AD. Yeah, you would need to do that. So let me jump to the conclusion here. So you're going to need to create the AD, the Azure AD, if you don't already have one that you're using for your enterprise. You're going to need to deploy your web app and add that application, because you'll need the URLs to register the app with the Azure AD. In order to force authentication in an MVC app, you use an authorized attribute, and connect and sync your local AD to Azure AD. So another one, and again, I've got a lot of questions in mind, and this is probably because I just took the exam and I've been studying so much for it that, I found these questions interesting to me, because it's like, really it's, the name of the game is rule out the answers that are not correct first. That's the name of the game, or the game that I play anyways. This is where that first exam tip comes into play. Know other products, so you know which ones to rule out first. So does anyone know the two answers for this one? Yeah, so Azure AD and App Service Authentication. So has anyone heard of the Azure AD domain services? Okay, so you guys have, or a few of you have heard of it. It's a product, it's out there. It sounds like it might have something to do with this answer, but it doesn't. Twitter Bootstrap was just, I used Twitter in the description, so threw it in there. So just another exam tip. There's so many components to authentication and authorization. It's kind of hard to cover them all here, but you should plan some time to explore them. Play around with it a bit so you get a general sense of how things work and what the pieces are involved when you're asked about them. So design for scalability and performance. This is the scaling up is to the question that was asked earlier. Scaling up is where you change your pricing tiers or one of the plans inside of a pricing tier. You wouldn't have to actually change pricing tiers to scale up. But it's more or less you want to get a bigger machine. You need more resources. So some applications will only run well with more resources, not more throughput. So the scaling out is where you add more throughput by dividing it across multiple instances. And most web apps, if you want them to be scalable, should be scaled to, or should be designed to scale out, not scale up, because it just doesn't make sense after a certain level to throw more hardware, more RAM at something. You need to move, if you have state that you need, which we'll touch on this later, but it's better to move the state out so that you can scale the logic up. Scaling, once you want to scale out, you can do it manually, so you can go in and say, hey, I want it to go up to 5 instances now. And it won't do it right away, but it'll start the process right away. And it'll move out to 5 instances. But you can also do auto scale. And auto scale is really useful, especially for scenarios where your site spikes, goes up and down. And the idea is if your application is getting heavy on the use of CPU, or it's getting a lot of HTTP in and out, or whatever the load manifests in for your site, you can set rules to say, okay, once you're at a certain percentage level, why don't you go ahead and scale out another one? And then scale out another one when you get to another level. And then once you've gone down to a level, take one out. So you can do these auto scale rules. And I've got the drop down there. So the metrics that you can use CPU percentage, memory percentage, disk queue length, HTTP queue length, data in, data out. And you can have multiple rules. So you can kind of get complicated with it. And one of the interesting things is you can schedule it, but then you can also do metrics. So you could also, so what that means is you have say the metrics are more geared towards your weekly loads spikes. But on the weekend, you may want to schedule it to go down to bare minimum so that the site's there, it's up and running, but it makes sure that it goes down to 1 instance versus having minimum of maybe 2 during the weekday. So schedules, using multiple rules, you can get really fine-grained on how you want it to scale for you, which is the nice thing. And you can also be notified when these scaling actions occur or have a webhook called. So here's another question. You're concerned about performance in a new web app. Yeah? What's the unit of scale? For scaling out? If you add an instance, you are whatever app service plan you selected. So say you've selected an app service plan that maybe it's a 1-core machine, 1.75 gigs of RAM. You're adding another one of those. Yep. It's kind of it's your compute resource that you're using to put stuff on. Yeah. And another key thing to remember is you can put multiple web apps on these app service plans. So one app plan doesn't equal one website. You can put multiple websites on it if you need to. But keep in mind, they're sharing the same resources.
Yeah, just remember that this stuff actually runs on hardware. It's just virtualized hardware. So it's going to have CPUs. It's going to have, in some cases, disk. It's going to have memory and all that stuff. So all of those resources count.
Definitely. So the question is, yes, so the question is about what does scaling up or scaling out look like? So what happens, you have your website up, say you have one instance of your website currently running. And then that's an app service plan, so you have your custom domain pointed at that web app. When you start to scale up, or when you say scale up, or a rule says scale up, it will bring up other instances. They won't be online immediately, but when they come online, then the traffic will start to be spread across those other new instances. Yes, so with web apps are different. So the question was, with the web app, does stuff get copied over from the disk? So web apps they're backed by storage, shared storage. So if you have 5 instances, they're hitting the same storage. There's the same shared storage. I mean, there's a caching layer in between, and you can configure some of that. But the great thing about that, if any of you have done cloud services, where cloud services and VMs work is, here's the stuff I want in my app, put it on this instance. So if you want another instance, you've got to somehow get that copy of stuff over to this new instance. With web apps, it's different. That storage is already there. They just spin up the web part, say, point at that directory. It's already there. Files are already there. They all share the same thing. Great thing about that deployment is you deploy to one spot, and all instances get that update. Where with cloud services and VMs, you've got to update each instance to get all of them across there. So it's very fast, very. Yeah, with web apps being platforms as a service, you don't have to worry about the load balancing. Yeah, good questions.
Do you have to be concerned with things like logs?
Do you have to be concerned with writing logs? Yes, you do, because it still comes down to the same thing. There are a lot of bells and whistles that you can turn on that will do logging for you, and logging becomes a difficulty when you start getting more than one instance. That's when it comes out. But you have the same problem. If you have a website running on a virtual machine or some other cloud host, it's the same scenario for logging. But there are different things that you can turn on and off, and different ways to get to those logs. So still no silver bullet there, unfortunately. Yep. Rolling releases with web apps, that's when you're getting into the advanced scenario. So one option you have, which we'll touch on later, is deployment slots, where you can say, I want so much traffic going to this slot, I want so much going to this one, and then you can slowly remove traffic from one, point it at another, and then swap once you get them done. You're getting advanced scenarios there, but it's doable. It's doable. But same thing with cloud services. Doing the rolling wasn't quite as easy either, but you can do it. You can do it. Yeah. Yes. Yeah, actually, we'll get to that. We'll get to that. So I'll just give you the answer here. So this was an auto scale question. You know, you've got concerns about performance. How do you make sure that your app is configured when it starts to get heavy load to fix the problem? You know, add another instance whenever it gets to 80%. Set up the auto scale, and it's good to go. So the next couple slides, or few slides, are based on, you know, design stuff. Kind of, if you're asked about scenario-oriented things, what are some things you should take into account? So you need to design for scale out, because otherwise you can't really get the most bang for your buck in the cloud. You need multiple instances, not bigger machines. So in order to do that, you need to remove state from your app. And if you have, you know, it's valid to need session to have your app know what the user had before they were last time here. That's a valid business reason in an application. But you need to distribute it. So Redis Cache is a great way to do that. And there's a session provider and a cache provider for UI components that you can use that wraps Redis on the back end. It's just a web config change once you set it up, and it uses all the other same stuff that ASP.NET uses anyways. And move to an asynchronous UI so that one call is not holding things up to get a response back. You know, have your UI take it if it's going to be long running, throw it in a queue and have a web job or some other processing take care of it and then return it back to the UI. Those are ways to get your app that may not be designed to be scalable to scale out multiple instances to move towards the scenario where you can get it to move to multiple instances. Now, once you've got your app there, how do you take it a step further? How do you get it to where, what if one data center goes down, or you have multiple users in all over the world or all over the US? Well, that's where Traffic Manager comes in. So that removes at one level to where it can now spread load across multiple instances or regions for you. So this is where you want to look at the slides for Traffic Manager. Some of the speakers have discussed. We're not sure if these are the three. We're pretty sure that these are the three that would be on the exam. The performance, failover, round robin, those are the three ways to choose what Traffic Manager should do with the traffic. Performance is going to be this. It's going to be the question. Your user needs to be hitting the closest data center. How do you make that happen? Well, that's what performance does. The one that's going to respond the fastest to that client or that user is going to be served the traffic. Failover is when one's down. How does it fail over? And by the way, a performance will also work as a failover because that one data center, if it's not there, it's not responding, it's going to fail over to the other one because it's going to be faster than nothing. And then round robin is just spreading traffic. Those were the three original traffic. There are now 4 of them, and I've got them in the notes on here, but we're pretty sure that these are the 3 that would be on the exam. The new additional one's called geographic, and they've relabeled the other ones. Performance is still the same, but you'll want to check your notes on. You'll want to check the notes on this one, but these are probably the ones that you'll have. CDN is another way to get your static data, like images, HTML files, media, that sort of thing, closer to the end user, so that it responds faster and not. It responds faster because it spreads everything out across the endpoints, which means that is more throughput for your application because it spread things out. Scales better. So you have a website that uses a lot of session state. You need to move the site to a web app in Azure. What choice? 2 choices should you make? This is kind of a tricky one. And again, this is mine. This is not a real exam. So there are 2 scenarios here that there are 2 and 2, and they're both two valid answers. But the answer is you need to start looking at moving your session out. That's what I was getting at here. So get your session state out of your web app. I'm running out of time, so I'm just going to skip to the answer here. Traffic Manager is very important, so you'll need to get to know Traffic Manager. Deploy, so you have multiple ways to get data out to a web app. Web Deploy is the one that's going to work with most developer tools like Visual Studio. It's also a command line, so you can script it. Kudu is a site that's deployed on every web app that also integrates with other build engines, so Visual Studio Team Services, GitHub Bitbucket. You can also drag and drop in a browser, though not IE. You can also do FTP, FTPS if you need to. And oh yeah, the bottom one here, infrastructure can also be set up with PowerShell scripts or CLI, so something to keep in mind. Update web apps with minimal downtime. This is your deployment slots. So deployment slots are other live instances of your app, and they have a DNS name. So if you have a staging environment and you create, so you have the production app, because that's what's created first. Staging environment would be a staging slot, and it would be more or less a copy, not a copy, but another instance of that you could swap with your deployment of production real easy. So you say, just swap these 2, and it'll move them for you. App settings, actually, this is more detailed than what I had in that listing there. So there are certain things that can be swapped, certain things that are swapped, and things that don't swap. So you'll kind of want to know which ones are which. App settings can be determined whether or not you want them to move. Same thing with connection strings. General settings, handler settings, diagnostic log settings, like if you have diagnostics turned on for blob storage or whatever, that stuff will actually go. So if you've turned that on in staging and you want to swap your staging with production, those settings will go. The not swapped are like custom domain names. So if you've got a staging site and you swap your production with staging, everything's going to still stay on production. So your domain, your SSL bindings, your scale settings, and endpoints are all going to stay on that slot, no matter which one you've got them configured in. I'm going to speed through these. I apologize, but I've got to get to the mobile stuff here. Design web apps for business continuity. Now this is, so business continuity and disaster recovery and backup are all interrelated. And there are a few other talks that you'll have today and tomorrow that get into more detail with other products. But what it comes down for web apps are, if you only have one data center or region deployment, you're going to need multiple instances. You don't need to get the SLA for web apps, but if you want business continuity, you do, because if it goes down, well then there's nothing else to pick it up. So you'll want to have multiple ones. And to really solve the problem, you need to have multiple deployments in multiple regions, and then traffic manager between the two. And then backup restore is an app service thing that you can turn on. Say, hey, I want my site backed up once a day, that you can then restore from. And optionally, you can use a database. Business continuity for SQL database. Multiple options. You can do point-in-time restore. So these options are really going to depend on what the terms are I have over there. You're going to kind of need to know what scenario you're shooting for. Do you have time for it to be down a few hours, or do you only have a few minutes? Those are the things you need to know to decide which answer is the best for you, and what cost is. Sometimes cost is a deciding factor here. So point-in-time restore comes with SQL database. So if that works for you, then it's already there. You're already paying for it. Geo restore is a little different. It's a little more. Restore from Azure Backup Vault, that's long-term storage for your database, or it wouldn't even be there. Active geo replication, that's going to cost more, but you get the most bang for your buck there. So you'll have it back online in a matter of minutes versus an hour or two if you have to restore it from a backup. So those are just business continuity things you'll need to know or be aware of. Data replication patterns. I'm going to skip through this. You guys just went through a storage one earlier, so I'm sure you know about it. One option with web apps is you can have a web job that copies data over across data centers, and that can be a really useful scenario to go with. I want to skip this. Again, I apologize. I'm just running out of time here. The tip. Oh yeah, so here's a tip. Not all products are built for high availability. So you'll need to know which ones are which. Like for instance, SQL database is, web apps is, Azure storage is, DocumentDB is. So if one goes down, it can easily come back up without you having to touch anything or deploy anything. VMs, you have to specifically do something. Redis, same thing, and search, same thing. You need to know what the SLAs are and what you'll need to do for that product to get business continuity. App service backup, this is just an item on the menu that you can choose. You get up to 10 gigs storage, schedule it, daily backup, and it's there. Again, I'm sorry, I am going to go through this pretty quick. Restore just says, hey, I've done a backup yesterday, can you restore it? And you can say, well, I need to restore it I want to restore the same site that you're on, or create another one in the same resource group and restore the website to that. Disaster recovery, these are just terms. How do you design for disaster recovery? Really, it's traffic manager, and then you need to look at your layers. You got to do your database layer and your storage layer before your web app can even run. So you kind of need to know your steps there. I talk too much sometimes. Okay, so something I did not cover, and you will want to pay attention to, is PowerShell and CLI. Look through the commands for those having to do with web apps and mobile apps, because there's a good chance there'll be a few questions on the exam in regards to those. It's not a coding exam, and you can pretty much figure out from the terms what it does, but take a look at it. Take a look at the terms. So with mobile apps are actually pretty simple. Here are the pieces. We've got the mobile device on one side. You've got a REST API that connects more or less to app services. And those are surfaced through APIs. Except for the push notification, that's different. That's going to be client specific and client store, like the Microsoft Store or the Apple Store. Those are the ones that are going to be doing the push. You'll have to configure those. So mobile apps. So mobile clients. So the mobile app is really just the client and the server. Yeah. The what? Xamarin? Xamarin? I might touch on it in a few slides. It's really just another choice, is what it comes down to. For this exam, Xamarin is just one of the choices. You get Android, you get iOS, you get Xamarin. You get 3 flavors of Xamarin. And then you can do C# for the store. So it's really just another flavor, another technology. It's the client app side. So for mobile apps, yeah, so this slide's just getting at, if you've never played with Node, check it out when it comes to this stuff, because there may be some important stuff you'll want to learn there. So with this kind of shows it here. This is just the client app. So with the mobile services, it comes down to the device code and the SDKs that they provide for you. Like, for instance, they provide you the SDKs to do offline data sync. And then they provide you SDKs on the server side to do the server side of that offline sync. So that's just the SDKs, no magic, because it's app services and APIs on the other side. And the magic really is reusing what they've already done for you with the SDKs. So offline storage is one thing. Sorry about this. I should have moved all those to the end. Mobile apps are part of app service, so you get all of this stuff. Just kind of reiterating that. The custom code is where the Xamarin comes in. So you can develop mobile apps in all of these. And you get all the goodness for the SDKs that they provide you to do the authentication tie-in, to do the offline data sync, to do the notifications. The notifications are going to be native in all of the client mobile apps anyways. The magic for the notification I get to in like 2 slides here. Server-side stuff, really with mobile clients you get 2 choices, Node.js or .NET. Whenever you set up the mobile app, you get to choose one or the other. I'm not saying you couldn't write an API in some other language or other technology and use it from a mobile app. It's just for the SDKs, this is what they're using. And then there's just some items that the SDK provides for you. Again, the data-oriented stuff, push-oriented stuff, and authentication. Okay, so securing mobile apps, almost exactly the same slide that was for web apps, because it's just app service behind the scenes. Some goodness with the client SDKs that tied into the devices authentication, but other than that, it's the same stuff. So here's where the magic comes in with the push notification. So with the mobile devices, the stores provide the notification that'll push the stuff to your device. So you've got the stores, which are the Apple, the Google, Windows, Amazon. All of those are there, doable without any of the Microsoft SDKs. Everybody can write those. However, the send push notifications using Notification Hub becomes magic, because now you can deploy a push notification across those devices. So if you've got Android code that'll send it to Android device, but you've got another one that'll send it to an iOS device, it would be up to you to manage those and say, okay, well, send it to this one now, send it to this one. The Notification Hub will take care of that for you. You just have to register all of your accounts for your application. And you get all of this goodness here, real easy. So that was pretty much the mobile apps part of stuff. And I won't let you go through these on your own, but since there are multiple languages for the mobile app SDKs, be familiar with the common objects. So look at the SDKs and the objects and what they do. You may not have to learn how to write one in iOS or Objective-C or Node.js or the Cordova Apache, which is JavaScript. You may not have to learn that, but learn what the SDKs do. And then the same thing with the server side, Node.js as well as C#, just to get a sense of what they do. They're very similar. I mean, with any SDK, they're not going to have a completely different object set and methods off of it. But that was kind of quick at the end. I apologize, I had to go so fast. So any other general questions about web apps or mobile? No? Okay, well that's it. There are a couple of labs. One's for mobile, and the mobile one is multiple languages. So you kind of get to pick. GitHub. Actually, I may not have it on here. Logged in as the other user. But if you look at the GitHub site, there's one that's called web, and then there's one that's called mobile. The web is kind of an exploratory one. You create a web app, and then you kind of explore the different features on the web app. And then the mobile app kind of points you to a multitude of different languages for the web or the mobile SDK and how to set it up. Those are geared off of the documentation. Very, very good examples. I've walked through a few of them. And that's it.